Hello, students. How are you all? I hope all of you are fine, safe, and healthy at your home. Having nice time with your family, enjoying this monsoon season. Okay, if you see around yourself, you will see the birds chirping, raindrops falling, and you must be enjoying bathing in that rainy season. So, in this video lecture, we would be learning law of constant proportions. In last video lecture, we learnt about law of conservation of mass. Here again, I am your mentor Shobna to teach you chemistry of standard 9. So let us begin with law of constant proportions. But before we begin law of constant proportion, what we studied last, that was law of conservation of mass, which says that mass, it remains constant even if chemical reaction takes place. Mass neither can be created nor it can be destroyed. And next, very important law of chemical combination is law of constant proportion. Proportion means here amount of atoms here, amount of their weight, you can say. So, how that proportion remains constant, what important points to be considered, which scientist gave his contribution in this theory, that we will learn in this point. Okay, so Lavoisier, along with other scientists, noted that many compounds were composed of two or more elements, and each such compound had the same element in the same proportions, irrespective of where the compound came from और who prepared it. ओके, दूसरे साइंटिस्ट ने जब अपना रिसर्च किया तो लेवोइजियर ने भी ये नोट किया कि कोई भी कंपाउंड ले ले तो वो एक से ज़्यादा एलिमेंट से बने हुए हैं और हर एक ऐसे कंपाउंड में सेम तरह का एलिमेंट है, चाहे वो कहीं भी प्रिपेयर किया गया हो या किसी ने भी प्रिपेयर किया गया हो, तो उसमें वो सेम एलिमेंट्स ही रहते हैं. फॉर एग्जाम्पल, let us take example of compound, say hydrogen gas. Its formula is H2. So if we consider hydrogen gas anywhere, it would contain the same element hydrogen in it wherever you go, or whosoever prepares the hydrogen gas in it, the reaction. ओके, सो कोई भी इसे प्रिपेयर करता है तो उसमें हाइड्रोजन एटम ही मिलेंगे, चाहे आप कहीं भी जाओ, चाहे कोई भी इस हाइड्रोजन गैस को रिलीज कर रहा है कोई भी केमिकल रिएक्शन के थ्रू. ओके, so it doesn't matter where the compound came from or who prepared it, the elements remains same. So that was the observation by Lavoisier. Now, example is given here that in a compound such as water, the ratio of mass of hydrogen to the mass of oxygen is always 1 is to 8, whatever the source of water. Okay, water चाहे हमें कहीं से भी मिला हो तो उसमें उनका मास का जो रेशियो है that would be 1 is to 8. Thus, if 9 gram of water is decomposed, we will get 1 gram of hydrogen and 8 gram of oxygen. Okay, they are always obtained. This mass, this weight would be obtained always. In the same way, in ammonia, which is having its formula NH3, 1 nitrogen and 3 hydrogen, so they are always present in the ratio of 14 is to 3, because you know that atomic weight of nitrogen it's 14 and atomic weight of 1 hydrogen is 1. So of it is of 3 hydrogen it would be 1 1 1 3 is a 3. Okay. So 14 is to 3 would be the ratio in case of ammonia. Whatever the method or source from which the ammonia is obtained, that ratio would remain 14 is to 3 in case of ammonia, and ratio would remain 1 is to 8 in case of water. Okay, so this led to the law of constant proportion, which is also known as law of definite proportion. Okay, this law of constant proportion is also called law of definite proportion, and this law was given by Proust, the scientist Proust. And the law says that in a chemical substance, the elements are always present in definite proportions by mass. Okay, we are considering it their mass because law of mass conservation is also followed at the same time. So this also include that proportions by mass. So in a chemical substance, elements are always present in a definite proportion. We cannot change its proportion. Okay, that proportion of elements, it is always constant. That is the law of constant proportions. So that proportion would be definite. It would be same everywhere. Wherever you found that compound, that doesn't matter. Who prepared it, that also doesn't matter. But that amount, that proportion would be definite. Got it, student? The next problem faced by scientists was to give appropriate explanation on these laws. Okay, this law was stated by Proust. Research on this law was done by Lavoisier, but that proper explanation was still required. So after this, British chemist John Dalton provided the basic theory on it. ओके, इन दोनों साइंटिस्ट ने जब इन पे अपना रिसर्च वर्क कर लिया, जब लोगों के लिए स्टेटमेंट प्रोवाइड कर दिया, तो फिर भी ज़्यादा एक्सप्लेनेशन की ज़रूरत थी, तो जॉन डेल्टन ने अपनी एटॉमिक थ्योरी दी और उनके ऊपर से फाइनली कुछ कंक्लूजन्स दिए जो हम यहाँ पे देखेंगे. Dalton picked up the idea of divisibility of matter. Okay, he took the base of research which was done by Lavoisier and Proust. Okay, जब भी कोई साइंटिस्ट वर्क करता है किसी नई थ्योरी पे, तो जनरली क्या होता है कि जो भी इंफॉर्मेशन अवेलेबल है, दूसरे साइंटिस्ट का कोई भी रिसर्च वर्क है, तो उनके बेस पर वो क्या करते हैं कि जो इन्फॉर्मेशन अवेलेबल है, दे टेक दैट इन्फॉर्मेशन एज बेस and after that they work further on that particular theory. So same thing was done by Dalton. He picked up the idea of divisibility of matter and which was till then just a philosophy. अभी भी उन पे कोई scientific explanations available नहीं थे. Okay, so Dalton took the basic idea and he took the name atoms, okay, which was Greek name given by Greeks. And here the mean word atom means, remember students, it was part of our previous lecture in which the atom, it's Greek, atom is a Greek name and its meaning was given. What was its meaning? Yes, atoms means indivisible, okay, means any matter, if we divide and divide and divide particular matter, then finally we will come up to the stage where it would not be divisible further. So at that time we will call it indivisible, means atom. So here atom is a Greek word and its meaning is indivisible. Okay. So Greeks, they and it was the name given by Greeks and say that smallest particle of matter are atoms. So Dalton's theory was based on the law of chemical combination, in which second law we were studying. Okay. So Dalton's atomic theory. It provided explanation for law of conservation of mass and also for the second law, law of definite proportions. Okay, and here what points are where which were given by Dalton we will see next. First of all, in this box some information on John Dalton was given. That is too interesting, students. So it says that John Dalton was born in poor weaver's family in 1766 in England. He began his career as a teacher at the age of 12. Can you imagine, students? He began his career at just 12 and he became a school principal when he was 19. At 12 he began his career as a teacher and when he was 19-year old he was principal of school. Okay, and we are just studying at this age. So we can say he was brilliant. In 1793, Dalton left for Manchester to teach mathematics, physics, and chemistry in a college. He spent most of his life there teaching and researching. Means you can say teaching was his passion. So teaching and researching was the main field of his profession or say career. In 1808, he presented his atomic theory, which was the great contribution to chemistry, and it was turning point in the study of matter. Okay, it gave uh, this research about element or atomic theory. It gave this research a boost. Okay, so it was turning point in study of matter. Now, what was the point which were given by Dalton's atomic theory? So, according to Dalton's atomic theory, all matter, whether an element or compound or a mixture. I hope now you are clear with these three terms, students, as we are done with chapter 1 and 2, in which we discussed these three terms in detail: element, compound, and a mixture. Okay, which type of mixture are there? What can be said compound, what is element? So I hope कि अब element, compound और mixture इन three terms में आपको कोई दिक्कत नहीं है. And if you still find any query, you can again revise chapter 1 and 2, in which we discussed mixture, its types in detail. Okay, and still if you find any query, drop me a message. So mixture is composed of small particles called atoms. Means here, Dalton atomic theory says that we take any matter. It may be an element, it may be a compound or mixture. So it contains small particles, smallest particles that are atoms. So some postulates of this theory may be stated as follows. You just can summarize the points which are so important. These points are: all matter is made of very tiny particles called atom. कोई भी मैटर ले ले, चाहे वो मिक्सचर है, एलिमेंट है या कंपाउंड है, वो बहुत ही छोटे पार्टिकल्स से बना हुआ है और वो पार्टिकल्स क्या है? एटम्स. सेकंड वन, एटम्स आर indivisible particles which cannot be created or destroyed in a chemical reaction. ओके, जैसा कि हमने लॉ ऑफ कंजर्वेशन ऑफ मास में कहा कि मास को ना ही हम क्रिएट कर सकते हैं ना ही डिस्ट्रॉय कर सकते हैं, सेम वे एटम्स जो है वो भी इंडिविजिबल पार्ट है. मतलब ना ही अब उनको और डिवाइड किया जा सकता है, ना ही उनको नए तरीके से क्रिएट किया जा सकता है. दे एग्जिस्ट इन अ नेचर इन देयर वे. ओके, सो वी कैन नॉट क्रिएट और डिस्ट्रॉय दिस एटम्स. ओके, atom of given elements, they are identical in mass and chemical property. And second point says that atom of different elements have different masses and chemical properties. At first glance, this point would seem difficult or it would seem similar to you, students, but both of the points are very important. You just see this clearly, that atoms of given element, they are identical in mass and chemical properties. मतलब अगर हम एग्जाम्पल लेकर एक्सप्लेन करें तो कोई एलिमेंट ले लेते हैं, तो उसके एटम्स है और वो अपने मास और केमिकल प्रॉपर्टी के तौर पे सेम रहेंगे. फॉर एग्जाम्पल लेट अस से कॉपर. तो आप कॉपर एलिमेंट का कोई भी एक टुकड़ा ले लें, चाहे वो 5 ग्राम का है, 10 ग्राम, तो अगर उसे देखा जाए तो उसमें सारे एटम्स हैं कॉपर के, वो सभी उनके पर्टिकुलर एक एक एटम को आप कंसिडर करें तो उनका मास सेम रहेगा. एक कॉपर एटम और दूसरा कॉपर एटम, दोनों का मास सेम रहेगा, दोनों की केमिकल प्रॉपर्टी सेम रहेगी. सो द सेम थिंग इज सेइंग दिस पॉइंट 3, that atom of a given element are identical in a mass and chemical property. Now next point says that atom of different element, okay, different element, they have different masses and chemical properties. अगर हम अलग अलग एलिमेंट ले तो उनके जो एटम्स है उनकी केमिकल प्रॉपर्टी और मास अलग रहेंगे. अब ये तो ऑब्वियस है भाई. चलो कॉपर और कार्बन ले लेते हैं फॉर एग्जाम्पल. So these two are different elements. Okay, students, copper and carbon both are different elements. Now, if you take carbon atom from carbon element and copper atom from copper element, then uh, both the atoms, carbon and copper, they are different. Of course, they are different atoms, so their mass would be different, their chemical properties would be different. Is that clear? Okay, next point says that Atoms combine in the ratio of small whole numbers to form compounds. Okay, atoms combines in the ratio of small whole numbers to form compounds. कोई भी एटम्स है उनसे कंपाउंड फॉर्म होता है, तो उनमें क्या होता है कि वो स्मॉल नंबर ऑफ एटम्स को मिलाकर एक कंपाउंड फॉर्म होता है और एक प्रॉपर रेशियो रहता है इनका. फॉर एग्जाम्पल वी टेक H2O, water. So water molecule, when this compound is formed, it is fixed that every time two hydrogen and one oxygen would combine and they will form atom. Okay, so here they combine in small numbers. अब ऐसा तो नहीं है कि चलो 40-50 एटम ले लिए एक साथ हाइड्रोजन के, बहुत ज़्यादा एटम ऑक्सीजन के ले लिए. इस तरह से नहीं, केमिकल कंपाउंड्स जो फॉर्म होते हैं वो स्मॉल नंबर्स में फॉर्म होते हैं और उनका रेशियो जो है वो फिक्स रहता है. ओके, सो एटम कंबाइन इन द रेशियो ऑफ स्मॉल होल नंबर्स. अब ऐसा भी नहीं है कि ये नंबर्स कोई भी फ्रैक्शनल नंबर्स है या पॉइंट वाले नंबर्स है. दे वुड बी होल नंबर्स टू फॉर्म कंपाउंड्स. ओके, अब आपने ऐसा कहीं सुना है कि कोई केमिकल कंपाउंड फॉर्म हुआ जिसमें 1.5 एटम ऑफ दिस एलिमेंट, 2.5 एटम ऑफ दैट एलिमेंट? नो, इट्स नॉट द केस. Numbers would be whole every time. Okay, either it would be 2 or 3, but it would be whole number. Next point says that the relative numbers and kind of atoms are constant in given compound. Relative number and kind of atom, they would be constant in given compound. We take any compound. Let us say hydrogen peroxide. So its chemical formula is H2O2. 2 hydrogen, 2 oxygen. Okay. So relative numbers. So in comparison of oxygen, the number of hydrogen would be, it would be fixed. Okay, it would be constant wherever you prepare, whosoever prepares it. Okay, so that chemical would have always number of hydrogen and number of oxygen in the ratio of 1:1. It would remain in this ratio only. If you take compound, say CH4, methane, so in that number of carbon and number of hydrogen would remain in the ratio of 1:4. That proportion, that would be constant. That is the law of constant proportion, student. Okay, so I hope you are clear with this explanation. Here we learned the law of constant proportion, in which we studied this uh, 6 important points finally given by John Dalton. Okay, now question regarding this explanation we would see in next video lecture, your in-text question. Okay, and if you find any query in this law of constant proportion, you can drop me a message. Okay, so we will see you in next video lecture. Till then, stay safe, stay sound at your home and do your homework regularly. Okay, students, thank you.